sometimes when we do problems involving integration, we get some really impossible to integrate functions, and then maybe are forced to use some sort of technology to come up with a numerical answer. So you're probably used to that from having it happen in Calculus 2, especially when you're trying to find the arc length of something. So I'm going to give you an example problem where we say set up, but don't evaluate the integral for calculating the surface area, but, well, I will use my machine, my software, to try to at least get us a numerical answer. And here's what it is. The function is f of xy equals e to the negative x times sine of y. And this is just to help me with my graph here. And R is the region where x goes from 0 to 4 and y goes from 0 to x. So y equals x would be a line coming up this way, right? So if you can imagine the line where y equals x, there it is right there, and y equals 0, of course, is the x-axis. So this triangle that I'm outlining right here is where our function lies. Above that, and we want the surface area of this goofy looking thing above this triangle over here, right? And so, of course, you know, when you do a partial derivative or so, which you need to do, partial with respect to x, well, the derivative of e to the negative x is just negative e to the negative x, so times sine of y, that was kind of easy. And of course the derivative of sine of y is cosine of y, so, and this is just considered a constant then, so that's pretty easy also. But unfortunately now our integrand would be 1 plus this squared, and you can see that would mean e to the negative 2x. When you square e to the x, you get e to the negative 2x. When you square e to the negative x, you get e to the negative 2x. When you square sine of y, you get sine squared of y. Same story with this. When you square e to the negative x, you get e to the negative 2x, and then you get cosine squared of y. Now, this is a bear of an integrand, but it does simplify it very nicely, because this sine squared plus cosine squared factors out and gives you 1. So we got the square root of 1 plus e to the negative 2x dy dx. Y goes from 0 to x as we described this triangle, x going from 0 to 4. Now, I tried to do this with MathCAD straight, and I'll show you what it looks like when I do that. Not much, right? So I was expecting a number answer. Well, if I had great enough software, maybe that would happen, but it won't give me an exact number for that. It just gives me this big expression. But what it did, I want you to notice, what it did when it gave me this expression, that is no longer a double integral. That is now a single integral. And my software, when it says exp 2x, that means e to the 2x. And this exp to the negative 2x, that's e to the negative 2x. So, golly, this is some kind of ugly mess here. But this integrand, which I wouldn't even begin to try to integrate, although if I were to suffer and had to integrate this, it's, oh golly, it's got a square root in it. I don't even think parts would work out nicely. And it doesn't look at all like a cinch or a coach, so it'd just be horrible. So my only option is to take this and try to get a numerical integration answer for it. So here's what we're trying to find, and if I do this, I can, you know, evaluate this with floating point answer, and when we do, we get this number, 8.11811, blah, 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 blah. So a little bit more than 8. Now let's at least see if the answer is reasonable, because if we looked at this triangle, the triangle has area, it's this way it's 4 and this way it's 4, so 16, and half of that would be 8. So the area of the surface above that triangle should be a little bit more than 8. And remember, this part where it goes up real high, that's not over our triangle, it's just this part right here. So that part right there barely stretches above the xy plane, so I think an answer 8.118 blah 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 is very reasonable.